Okay, great job on the rewind. Everyone did. I saw a lot of people showing their work, which I appreciate. And then I expected number 4 to trip people up, and it didn't really. There was only one thing that people made mistakes on. Remember what I said on Friday, which is before you even start the problem, decide what your answer is going to be, negative or positive. So if I'm looking at this, since this one's negative and this one's positive, my answer is going to be negative. So then I don't need to worry about the negative sign in the actual work. I just know my answer is going to be negative. Which one do I want to get rid of? The 2/3 or the 1/3? 2/3, because that's the one that's with the x, and I want to get x by itself, because again, the goal is always isolating the variable. So I'm going to multiply by what? 3/2, which I do over here, and I saw everybody pretty much do that, which gave you what? 3/6, and it was a negative, and then some people reduced, and if you reduced, you ended up with -1/2. Do you have to reduce? No, I don't really care what you do. Okay, so you do not have to reduce if you do not want to. Your calculator will reduce for you if you want it to. Okay, so I'm not testing you on if you can reduce. I just want to know that you can do the algebra. The biggest thing is, though, if you're going to reduce it, if this is negative, your answer here still needs to be negative. So don't forget to carry that negative over into your answer. All right, so everything we talked about on Thursday and Friday was single-step algebraic equations. So what we're going to talk about today is solving two-step or multi-step equations. So that's our goal for today, is to be able to solve two-step or multi-step equations. And multi-step would just mean what? Could be more than two, right? Multi is just like multiple, so more than one-step equations that we're talking about today. So when you're thinking about these, still the goal with algebra is always to get x where? By itself. So we want to get rid of all the stuff that's with x. So in this case, what are we going to get rid of? Don't tell me how, but what do we need to get rid of? The 2 and the... I don't want to get rid of the x. I can't, yeah. So I want to get rid of the 2 and the 3. Very good. I have to get rid of those two things. How do I decide which one to get rid of first? You flipped it. So I have to get rid of the stuff that's farther away from the variable first. So in this case, I'm going to get rid of the 3 first. But the actual way that we decide, how do you decide? Let me back up for a second. How do you decide when you have a problem like this? How do you decide what to do first? Order of operations, right? So PEMDAS tells us that in this case, we would do what first? Multiplication, right? So we want to do multiplication first because of order of operations. When we're doing these inverse operations, we still are like governed by the order of operations, except since we're doing inverse, that means we're basically doing everything what? The opposite. So instead of doing order of operations PEMDAS, we're going to do order of operations SADMAP. So we're going to go backwards. You're basically following order of operations, but we're going backwards, okay? So that means instead of doing multiplication division first, I do addition subtraction first. So in this case, this plus 3 is what I want to get rid of first, because I'm doing backwards order of operations. So again, I'm going to write PEMDAS. But I'm working from the bottom up, okay? So I'm working from the bottom up. So how would I get rid of a plus 3 first? Minus 3, right? So I'm going to do minus 3 here. Where else do I do it? On the other side of my invisible wall, which goes through the equal sign. Very good. So minus 3 here, minus 3 here. And that gives me what happens here. They cancel out because they give me what, really? 0. And do we have to write the 0? No. So again, we say cancel out, but is it really just canceling? It's turning into something, right? It's just something we don't need. So I don't need to put that, so that's gone. So what do I have left? 2x equals, and then what do I have here? 8. Very good. And now how do I finish this? Divide by 2. So I divide by 2 here, divide by 2 here, and what do I end up with? 4. Good. So x equals 4. How do I check it? Plug it back in. Do you have to do it? If you're getting everyone wrong, should you do it? Yes, probably. Okay, so I'm going to do just a mental check. 2 times 4 is 8. 8 plus 3 is 11. Okay, so I'm going to get rid of those. That worked out perfectly. X equals 4. All right, The other way to think about it, if you don't want to think about going backwards order of operations, is what Nick said at the beginning. Get rid of the stuff that's farther away from the variable first. Think about it like x is trying to hold on to everything that's near it. And so it's easier to get rid of this 3 because it's farther away. If you think about it like, this is weird, go with me. If you're on like a safari and a lion is trying to figure out which antelope it's going to go after, which one does it go after? The closest, the one that's like farther, like that one that's limping in the back, that is like farther away from the herd, right? Why would you go after that one? Yeah, it's the weakest, it's the easiest one to get rid of, right? So think of 3 like that limping antelope, okay? It's weak, it's like farther away from the x, so get rid of it first. That's going to be the easier one to get rid of. And then 2 is closer to x, it's holding really tight to the x, so get rid of that one last. So get rid of all the stuff that's far away because it's easier, and then we deal with the stuff that's close. And again, when we say easy and hard, none of this is like, subtracting 3 is not actually harder or easier than 2, but it's just think of it that way because then it can help you remember what to do first. Okay, so what would we do here? I want to get rid of the 12 first. What kind of 12 is it? It's a negative 12 or a minus 12. So how do I get rid of a minus or negative 12? Plus 12. Where do I add the 12? To the 48. Good. Not to the what? Not to the 5, because I can't. They're not like terms, so I can't add them together. What happens to it here? Goes away. What do I have left? Equals 60. And then how would I finish? Divide by 5. And I end up with x equals 12. Check my work. What's 5 times 12? 60 minus 12, 48. Again, if you have a calculator, it's really easy to check your work. And you guys can grab a calculator before you go to your boards, okay? So that's pretty much all there is to it. That's solving multi-step equations. We're going to look at some that are a little bit harder, okay? So we're going to look at a couple that get a little more complicated. But again, we're not going to freak out just because we see a fraction. We're just going to do the same process, right? What's the stuff that's farthest away from x here? The 1/2. You've got 2 options. You can either keep it as a fraction or you could change it to a decimal. A lot of you guys would rather work in decimals. Typically, I like working in decimals too, but what do you notice about 1/2 and 3/2? What do they already have? They have the same denominator. So is it going to be a lot of work? No, because they already have common denominators. So I'm just going to keep them as fractions because since they're already with common denominators, it's not adding a lot of work. So I'm just going to do it. What kind of 1/2 is this, positive or negative? How do you know it's positive? There's no negative, exactly. If there isn't a sign, we assume it's positive. So how do I get rid of a positive 1/2? Minus 1/2. And if I do that here, where else do I do it? Over here, minus 1/2. What happens to it here? Goes away. And what do I have left? Equals, what's this? 1. 3 minus 1 is 2, which gives me 2 over 2, which is the same as 1. I'm going to turn it into 1 because it's a whole lot easier if I turn it into 1. So I'm going to rewrite this as 3x equals 1. A lot of you guys just did that mentally in your heads, which is totally fine. Do that. All right? How would I finish? Divided by 3, divided by 3. What happens to these? They go away. What do I have left? X equals 1/3. Exactly. Emmanuel, could you do that division? Yes? Would I? Why not? Yeah, I'm lazy, right? I don't want to. I don't want to do the division, so I'm not going to. So I'm going to leave it as x equals 1/3. I like fractions, okay? I'm going to leave it that way. Could you do it on your calculator? Yes. Does anyone know off the top of their heads what that would give you? 0.3 repeating forever for the rest of your life. So is that a rational or irrational number? Rational. It's rational because does it have a pattern? Yes. So it's a rational number. Good. So it goes on forever and ever and ever. So you could also write this as, you could also write this as 0.3 repeating. Okay. Either of those is fine. Trust that I will probably leave it like that. okay? But if you like them as decimals, put them as decimals. I can always figure it out when I'm grading. Make more work for me when I'm grading, that's fine, I don't care, okay? Whatever you're more comfortable with. We're going to do one more example before you guys go to your boards. Okay. Okay. What's my weak antelope here? 4, because it's off kind of by itself. So how am I going to get rid of, Elijah, that plus 4? Subtract 4. So if I subtract 4 here, where else do I do it? On the other side. Okay. 12 minus 4 gives me 8. And then I have x over 7. And again, we're not going to freak out just because it looks like a fraction. This is what kind of math? Dividing. So how do I get rid of division? I'm going to multiply in this case. Where do I want the 7? On the top. Because I want it to do what with this 7? Cancel out. So it needs to be on the top. So 7 over 1, which is the same as just what? 7. So over here, I'm just going to multiply by 7 over 1. What happens here? They're gone. And all I have left is x. And then over here, what's 7 times 8? 56 over 1. Do I need that 1? No. So this is the same as just saying x equals 56. Okay? That's it. All right? So again, what did we get rid of first? The 4, because it was addition. So we're going backwards order of operations. Addition is down near the bottom, so we start there. And we get rid of it using subtraction. And then the last thing we did to get rid of division, we multiplied by the reciprocal. Reciprocal is just, what does reciprocal mean? It's a fancy word for flip it. It's a fancy word for flip it. So we flipped the 7 from the bottom to the top. Okay? And that's why we ended up multiplying 7 times 8. All right, on your way, if you want to grab a calculator on your way to your boards, go ahead. You guys are going to do all 6 of these. All right, let's talk about number 6. Let's talk about number 6. So, number 6 is kind of weird. Emmanuel, why is number 6 kind of weird? Yeah, it doesn't really follow SADMAP. Because in backwards order of operations, you want to get rid of them plus 5 first, right? So you want to get rid of the plus 5, but that's not how it's going to work. Think back to when we were doing simplifying order of operations problems, and we had like 3, 2 plus 5 over 5 plus 7 times 6. What did you have to do to solve these? Okay, so you'd start with the parentheses, yeah, okay. But then what? Maybe I could use the distributive property. But when it's got that division bar like that.
Oh, you do them separately.
Yeah, you look at them like separate problems. You had to simplify everything on the top, which you do the parentheses first, so you guys are right there. And then you do everything on the bottom, and then you would do the division, right? So the last thing you ended up doing was the division. This is like that special case where division happens at the end. So it's the first thing we need to get rid of here. So the first thing I want to get rid of actually is not the 5, but the divided by 6. How do I get rid of a divided by 6? I multiply by 6 over 1 because I need the 6 on top to get rid of 1 on the bottom. So then over here I'm going to multiply by 6 over 1 or just 6. Okay? What happens here? Yeah, those are gone. So then what do I really have left? 5 plus x equals, and then what's 6 times negative 1? Good. How would I finish this? I heard 2 different things. I heard add 6 or subtract 5. What am I trying to do? I want to get x alone, so what do I need to get rid of? The 5. So I want to subtract the 5 because that's what I want to get rid of. And then I end up with x equals, signs are the same, so negative 11. All right? So this is a weird one because it doesn't really follow order of operations. Just like over here, technically this did not follow order of operations because you have to simplify everything on top and the bottom. That's basically what we're doing here. We're simplifying the stuff on the bottom and then getting rid of it, which is, again, why Nick's rule might help a little bit more. The stuff that's farther away, 6 is a little bit farther away, get rid of that first, okay? Always, a way to check yourself is to go back and plug it in. So if you did it the other way and you ended up, I think, with negative 36, right? That was what people were ending up with. So if you ended up with negative 36 and you plug that in, 5 plus negative 36 gives me negative 31, which is not going to divide to give me negative 1, okay? So if you're not sure, try plugging it in. If it doesn't work, then you know you did something wrong, and it might be one of these like special trick cases. All right. What's going on here? Do not forget, guys, that all of this will be posted, so if I write something too fast or if I'm talking too fast, you can always go back and listen to it, or you can look at it on Google Classroom. What's happening here? If you were just describing to me what's going on in this problem, what do you see in front of you? There's parentheses, okay. Which means we're probably talking what property? Distributive property. So we've got two ways we can do this. We've got simplifying by doing the distributive property, or we know that the distributive property, when there's no symbol here, means what kind of math? Multiplication. So your other option, you've got two options. I'm going to do both of them. I'm going to distribute it, and then I'm going to cancel out the multiplication, and I'm going to let you guys decide what you think is easier. I know what I think is easier, but you guys, I want you to feel free to do whatever you want, okay? So first I'm going to try by distributing. Okay, so 4x plus 7 equals 23. So if I'm distributing, what am I distributing here? The 4. Elijah, walk me through it. What do I get? Okay. Good. So I've got 4x plus 28. And then that equals what? 23. Okay. Now this is just like every other multi-step one we looked at. What would I do first? All right, and I end up with what? This goes away, so all I have left is 4x. And then what do I get here? Negative 5, because the signs are different. So I subtract, and I keep the sign of the bigger one, which is 28 in this case. So minus is negative 28. And then how would I finish? Good. And then I end up with, good. Could you do the division? Yes. If you did, you would end up with negative 1.25. I don't care what you do. You can leave it that way. You can leave it at negative 5/4. So that's one option. All right. My other option is to just get rid of the 4 first. So I'm going to get rid of the 4 first, and I'm going to do that using division, because again, what kind of math is it when it's right next to a parentheses? Multiplication. There is no symbol, so I'm just going to divide by 4 and divide by 4. What does this give me? That goes away. It's gone. So what do I have left? X plus 7 equals 5 point something. So 23 divided by 4 as a fraction. And then how would I finish that? Minus 7. Minus 7. So x equals 23 over 4 minus 7. This is a great time to use a calculator. Don't worry about it right now. There's two options for how to do these. This way, probably easier for this one. Okay? This way might be a little bit harder. This way might be easier, though, if the problem were like this. All right, what changed? What did I just change? The total. Instead of 23, it was 20, which means what happens when I divide it by 4? I end up with a whole number. So now I have x plus 7 equals what? 5. And now x actually equals, all right, that way might be easier now. Okay? So there's two different ways to do it. Distribute first, or we can do the division first. I typically look at the problem and say, if it goes into it, I'm going to do the division first, because then I'm working with smaller numbers, and I like smaller numbers better than bigger numbers. So it's really up to you. Your options are whatever you want to do that makes your life easier. So when you're looking at these practice problems, which are all this style, you guys are only going to do the first 4, so just that first row. When you're looking at these, for instance, number 1, is 48 divisible by 6? Yes. So you might want to divide first rather than distributing, okay? Because otherwise you're going to do 6 times 3 and you end up with 18 and it's just a bigger number. Whatever you want to do doesn't matter to me, okay? Try those first 4. I'm going to cut you guys off in a few minutes so you have time for your exit ticket. So if you don't finish them, that's fine, but try those.